Okay, in this video we are going to look at static and slide and friction. We're going to look at it a lot like a lot of the block problems are in the homework. So let's make a block. Let's say we have this box. It's sitting on the horizontal ground or a horizontal surface, and it has a mass of 5 kilograms. Not a force, but a mass of 5 kilograms. But it does have a force applied to it, and that is a horizontal force of 30 newtons. So it has a force applied of 30 newtons. Now we're going to give it some other information. Coefficient of static friction equals 0.8 in this case. Again, it's just a number I made up. And the coefficient of friction or slide-in friction is 0.6. Again, static friction should always be higher because it is harder to get the block moving than it is to keep moving. And we're going to ask the questions, what is the acceleration? And what are all the forces with their magnitude? So we're going to be looking at the acceleration, and we're going to find all the forces, how much they are. Okay, so a couple we know. We know that there's a force of gravity, and that is down. We know that there's a normal force, and that is up. And we know there's some type of friction to the left because I'm moving it, or at least trying to move it to the right. Friction is the force that opposes motion, so it's going to be the opposite direction. So I'm just going to put F there now. We're going to fill it in. All right, so force of gravity equals m times g, or 5 times 9.8, works out to be 49 newtons. Hopefully you could calculate that one. And in this case, the normal force is the force that stops an object from falling through the surface.
Mr. Berube down 402.
So that in this case will also be 49 newtons. So I know those two. Now I've got to look at the friction. So let's assume in this case that the block is initially at rest. So if we're looking for the acceleration, the first thing we have to figure out is, okay, so the first thing we have to do is see if we could overcome static friction. So static friction is less than or equal to the coefficient of static friction times the normal force. So in this case, static friction is less than or equal to 0.8 times the normal force, which is 49 newtons. Static friction is less than or equal to, so static friction in this case is less than or equal to 39.2 newtons. So I'm going to, So I'm going to say that static friction can get as high as 39.2 newtons. So the math works out to be 39.2. What does that mean? That means static friction can be less than that, and that's the highest it can get to. So friction is the force that opposes motion. Static friction is a form of friction. So the force applied is 30 newtons, and static friction can get as high as 39.2 newtons. So static friction can get higher than the force you're applying. You don't apply a force that goes above what static friction can get to. So that just tells us one thing. We don't have to calculate the acceleration. The acceleration is 0. You're not applying a force strong enough to overcome friction. So friction is 0. I'm sorry, the acceleration is 0. It's not moving. Now, with that said, we also know this. We know that the sum of the forces equals mass times acceleration. So I'm just going to make myself some room here. And Newton's second law tells us that the sum of the forces equals mass times acceleration. That's probably good. There we go. And in this case, we've already determined it's not going to move, so the acceleration is 0. So that means the sum of the forces is 0. All the forces add up to 0. That doesn't mean the static friction is 0. That means the sum of the forces, when we add them up, they add up to 0. So if I go back up here static friction. I know I have static friction because it's not moving. And I also know that all four forces add up to 0. Well, 49 up and 49 down, that adds up to 0. I have 30 newtons to the right, so I must have 30 newtons to the left. And there we go. We know our acceleration, and we know all of the forces in this case. Let's look at this in a slightly different situation. We still know that the static friction, coefficient of static friction is 0.8, so I'm not going to change that. It's the same surfaces, it's the same block, and the coefficient of friction is 0.6, so I didn't change that. We have the same block, and it's still 5 kilograms. It's going to be the same questions. What's the acceleration and all the forces? The only thing that's different is we are going to apply a different force. We're going to pull harder on it. So let's say we apply a force of 40 newtons. And that is the force applied. In the last case, the static friction was equal to that because sum of the force is 0. The static friction isn't higher, it doesn't win, it's just enough to cancel it out. But this time we intentionally picked a force applied that's greater than static friction. So we know something. Well, first of all, we know the force of gravity is down, and we know it's 49 newtons. We didn't change that. We know that the normal force is up, and we know that is 49 newtons. We didn't do anything that would change that. But we do know we applied a force that overcomes static friction. Static friction reached a maximum value that was less than 40. So we don't have static friction anymore. We applied a force that would make the block move. So I now know I have kinetic friction because I overcome static. And how much kinetic friction do I have? Well, kinetic friction is not a less than or equal to statement. It is an equal to statement. It equals mu times the normal force, or in this case 0.6 times 49 newtons, which equals 29.4 newtons. So we don't have to think about how much kinetic friction we have when we do the math. It is simply what we calculate. It is 29.4. Static friction takes a little more thought. Kinetic friction doesn't. When you multiply those two values together, as long as you have static friction, that's the amount. So we have, this one's going in a slightly different order. In this one, we could find all the forces and then find acceleration. The last one, we found the acceleration first, and that allowed us to find all the forces. All right, but we're using the same equations in both problems. We found all the forces. Now sum of the forces equals mass times acceleration. Again, sum of the forces, all the forces added up. So I've got 49 up and 49 down. Those add up to 0. I have 40 to the right and I have 29.4 to the left. So it's still addition, but this number is a negative number. It's in the opposite direction. So that works out to be, well, the sum of the forces is 10.6 newtons to the right, and positive tends to mean to the right, but I'm going to put an arrow there to the right. That equals mass 5 kilograms times acceleration. And I'm going to do it on the next screen just to watch the units cancel out. I'm looking for an acceleration, so I'm expecting units of meters per second squared. So I have 10.6 kilogram meter per second squared divided by the mass, 5 kilograms. That equals acceleration, and that works out to be 2.12 kilograms cancel out. There we go. 2.12 meters per second squared equals acceleration. It's a positive acceleration. It's in the same direction, so it's accelerating to the right. Now I've done everything for that problem also. So there is a situation where the block doesn't move and we have static friction, and then a situation where it does move and we have kinetic friction.